Welcome to another screencast. This one is about stationary fronts, and we're starting again with the textbook rendition diagram of a stationary front. You can see that the warm air mass is moving to the left and the cold air mass is moving to the right, and they balance each other and they don't move, hence the term stationary front. Think of a stationary bike, it doesn't move, right? Another textbook diagram. You can see the warm air is moving to the right, cold air is moving to the left. In between where they meet, you have cloud formation because the warm air is forced above the cold air, but because they're balanced, they don't move each other, and then that front stays in that spot or remains stationary. So if we take a look at what that is, as a cold air mass, and if we label it as such, and we have continental polar, and then to the right we have a warm air mass or maritime tropical. And if we see that the directions are in opposite directions, that they're moving, and as they move towards one another, when they collide, that warm air will be forced above the cold air, and we'll get cloud formation, we'll get precipitation. And the thing is, the front doesn't move. They're kind of like equally balanced. The front stays there, and therefore you get a stationary front. It will stay stall out in the area or stay there for a while. Looking at it from a map view, we could see continental polar cold air, and here's our little compass rose from the north, probably from Canada A, and warm air, maritime tropical air mass from the Gulf of Mexico. And the cold air is moving south, the warm air is moving north, because you can see the direction is indicated by the side in which the symbols are drawn. And so they move towards one another, and then eventually they collide where they meet, and they're balanced and they don't move one another, and we get the formation of a stationary front. Cold air exists here, warm air exists here, and here would be our area of precipitation. Neatening it up a little bit, the appropriate symbol for a stationary front is cold air on one, cold front on one, warm front on the other, cold on one, warm front on the other. And again, the symbols need to be on the side in which it's moving. So the warm air mass is moving to the north over here, and the cold air mass is moving to the south from here. It's a pretty quick, easy, straightforward situation. So, stationary front, when a cold air mass collides with a warm air mass and they don't move each other, and the front does not move, that's when we get a stationary front. And another important piece is that if the stationary front remains stationary, or doesn't move for too long, flooding can occur. Doesn't mean it's going to occur, but it can occur. That would be the risk with the stationary front. Which leads us to this last diagram. When you're going to the movies, and you can see the little map of the seats with people of average proportion and seats with supernaturally tall people, and these are the seats that you carefully selected. So I hope that you enjoyed this screencast. Enjoy your day. So before I leave you, I feel compelled to show this to you. This is one of the best videos I've ever seen. Probably one of the best 18 seconds ever. And I'll let it play once, then I'm going to make a comment on it and play it again. So enjoy it. It's outstanding. Okay, now for my commentary on it. So, first off, great idea. Great. He's holding a book in his hand. He's got a robe on. Coffee in the other hand. Outstanding. Sliding. Outstanding. Great use of slow-mo. Great music selection. All outstanding. Probably my favorite thing, though. I like that. That's great. And then the look away. Perfect. Good hairdo. Little ponytail in the back. I love this guy walking up, just completely ignoring him. Like as if nothing's happened.